the main area of research I'm working in is applied statistics, and especially applying statistics to difficult problems where you have large data sets, where you want to extract from data with a lot of noise, a lot of variation, a trend, how things develop over time or over space or over both. And we call that smoothing in our field. And a modern name is functional data analysis. That's now the sexy name for this area. And I've been working a lot in this area together with a friend in the United States, Brian Marks, but also together with Maria de Ban here in the department, and other people like Ian Curry in Edinburgh. The application. Now, an application is, for instance, mortality tables. If you collect data on how many people die each year at each age, and then over the years you get a large table with age from 0 to 100, and the year from, say, 1900 to 2015. And people are interested in finding out how mortality develops. You know that people live longer these days, yeah? And if you are in social security or in a pension fund, then you want to know how the development is because if people live longer, you have to pay pensions more and longer, yeah? And so that's very important. And we have been developing methods to analyze such data so that you can see the trend of what we call mortality over ages. A similar problem is in agriculture, where people study, they breed many different types of one plant, and then they want to know which ones are the most productive, which ones produce the most grain, or the most sugar if we talk about sugar beet, or the best potatoes if we talk about potatoes. And these plants, they are planted in fields, and then their properties are measured, how much they yield. But it would be nice if an agricultural field was just like a billiard, completely flat, and everywhere the same fertility, but that's not the case, so you have to correct for that. And we have been developing methods to derive from data from an agricultural field how the local variation in the field is and how you can correct for that so that you get better numbers for the individual plants, how good they work. Let's work together with Maria and Diego Aima, and there the goal is to combine data from different sources. So you need to know how many people live in parts of, say, Madrid, yeah? But you also have a cancer registry that studies how many people die from certain types of cancer. Now the boundaries of those areas, they are not the same. So you have census districts, yeah, they have certain boundaries. You have, for the registries, you have certain boundaries, and they partly overlap. They do. And we are working on a method that combines those data into one data set so that you can make a map of the city, of the, say, the intensity of certain types of cancers, combining these awkward sources. Yeah.